morning. Today we will discuss about some questions from differentiability. Okay, so here there are two questions. First question asks why a real valued function f of x equals to mod x is not differentiable at x equals to 0, but a real valued function f of x equals to x mod x is differentiable at x equals to 0. Okay, so we are using two different methods. One is graphical method and second one is the use of the derivative rule. Okay, so first one is the graphical method. Here f of x equals to mod x is defined like plus x when x is greater or equals to 0 and minus x when x is less than 0. Okay, so the graph of the function is what? The mod function. F of x equals to plus x is y equals to plus x in their respective domain. X is non-negative, and minus x y equals to minus x on their x is less than 0 domain. Okay, so this is the graph. Now B-shaped graph that is very famous. Okay, so since there exists a sharp corner point x equals to 0, so function never be differentiable at x equals to 0. Okay, so now we can plot for this function f of x equals to mod x. So the graph of this function is what? F of x equals to x square for this domain. So this is the graph, and f of x equals to minus x square when x is less than 0. So this is the graph for the negative domain. Okay, so here there is no sharp corner point. So there is no sharp corner point. So function is differentiable at x equals to 0. Moreover, this function is not differentiable at x equals to 0, but differentiable throughout the real number except 1.0. And this function is differentiable throughout the entire domain real number. Okay. So now we can use a second method, a derivative rule. Here f of x is mod x, that is defined by plus x when x is greater or equals to 0 and minus x when x is less than 0. So take a derivative of this function. So f dash x equals to derivative, that means here the first derivative. Okay, so f dash x equals to plus 1 when x is greater or equals to 0, minus 1 when x is less than 0. So here f dash x at x is positive. So right hand derivative, that is first derivative